All right, guys, quick one today. So over the next few days, we're going to talk about the growth of different types of functions. Today, we're going to talk about linear growth. So it's most basic things we've been looking at. And we talked about what linear growth looks like on a table, right? So we said if we were given a table of values, if we were given something, like x and f of x, right? Which is our new y. Right? If we had f of x and f of x, if we saw something look like this, 2, 3, 4, 5, and we saw this was, I don't know, 10, 20, 30, 40, that this was linear because these were going up by 1, right? And these were all going up by the same number, which was 10, right? So we said for sure that this was linear, right? Because as long as these were all going up by the same amount, that was good. So from a graphing standpoint, what does this look like? So I need some smaller numbers so I can actually graph this. Let's pick some easy ones. Let's go 0, 2, 4, and 6. So 2, 0, so 1, 2, 0. 3, 1, 2, 4, 1, 2, 3, 4, and 5, 1, 2, 3, 4, 5, 6. So if you know, it's going up by a constant amount. As this is going up by 1, these are going up by 2, right? So you build like a little flight of steps. Or we could say this is going up by 2, this is going over 1, okay? So what we would say is that the slope of this is constant, that it doesn't change. So if we kind of traced a line through this, it should look something like that, right? And that essentially it's always the same amount, that essentially you're always going to go up to over 1, up to over 1, up to over 1, right? We kind of built this little flight of steps. So eventually they will be more complicated, but all of your questions today, your change in x is always going to be by 1. Okay? So in other words, this change is always going to be by 1. What they're going to want to know is what is this change? What is your vertical change? In other words, what is your change in y values? Okay? And there's two ways to do this. They can ask you like this from a table, or they can ask you giving the actual equation. So let's think back real hard about what the equation for this line would be. Blow my nose. I'm going to keep sniffling. It's going to drive you guys crazy. Hold on. Okay, sorry, I'm back. I know that didn't take any time off for you, but sorry. I was blowing my nose. I was sniffling all throughout a video the other day, and I realized how insanely annoying it was. So I'm going to make a point to try not to do that anymore. Okay, so again, let's talk about this. The graph of this one, again, we're starting at -4, right? And we're going up to over 1, up to over 1, up to over 1. So we would say that in this case, we were writing this in, f of x equals mx plus b, what we used to call y equals mx plus b. Well, again, my slope was 2 over 1, right? So don't forget that m is equal to your change in f of x, what we used to call your change in y, over your change in x. So that's going, for every 2 I go up, I'm going 1 over. And my y-intercept is -4. Now, for our purposes, we don't even really care about the y-intercept because all they want to know is what's your rate of change. This kind of tells you where you're starting from. So if your interval is 1, this is your slope. Okay, so if they said, hey, how is it changing between, I don't know, let's say 6 and 7? What they want you to do is they want you to evaluate this function at 6 and 7. They want you to say, hey, what's f of 6? Well, it's 2 times 6 minus 4, which is 12 minus 4, which is 8. So f of 6 is 8. And f of 7 is going to say, well, that's 2 times 7 minus 4. Well, 2 times 7 is 14. 14 minus 4 is going to be 10. So as these change by 1, these change by 2, which is just going to be this number right here. Now, if it's changing by other numbers, we'll kind of cross that bridge when we come to it. But right now, since they're only changing by 1, they want to know, hey, what is your slope? How much is it changing by over this interval? Okay. So let's take a look at some of the questions that you guys are going to see today. It's nothing crazy. So they gave this graph that says, hey, how does h of x change from x is equal to 3 to x is equal to 4? Well, that's the interval of 1. From 3 to 4 is 1. So if you take a look at this, it actually doesn't matter where we measure it from, okay? But from 3, it's at 3, and at 4, it's at 4, right? So when I plug in 3, I get out 3. If I plug in 4, I get out 4. So when your x is changed by 1, what did your y's change by? They also change by 1, right? So again, as your x is changed by 1, your y's change by 1. So, and it's going up, so it's increasing by 1. Nothing crazy there, right? From x is equal to 2 to x is equal to 3. So from 2 to 3. So at 2, I got out 6, and at 3, I got out 9. So again, if we look, as x changed by 1, y changed by 1, 2, 3. Okay? As x changed by 1, f of x changed by 1, 2, 3. So it's going to increase by 3. There are some other answers here. Don't worry about, you only have to worry about these. These factors and percents, that's going to be the more complicated stuff we look at with quadratics and exponential functions. So you can kind of ignore those answers for now. They're going to seem like, well, why are they putting these same answers for all these problems? Because they're coming in the future, okay? So from t is equal to -8 to t is equal to -7. Well, again, t is on the x-axis, g of t is on the y-axis. So between -8 and -7, again, as I went up 1 from -8 to -7, I actually went down 1. So this is going to decrease by 1. From -3 to -4, I'm sorry, from -4 to -3, so it's from -4 to -3, so I went over 1, I went down 2. So decreased by 2. So again, if you see the line is going down, it's definitely decreasing. If you see the line is going up, it's definitely increasing. Okay? Again, these percentages don't really matter because the linear growth is always by the same number, so it won't be by 100% growth or by 200% growth. That can't happen with the linear. By definition, wouldn't be linear. So again, from 4 to 5, I went up by 1, I went up by 2. Oops. Okay. So let's take a look at some of the other questions you'll see, and we'll be done for the day. That was it. There were some questions I want to look at. Yes. Okay. So if you're given it in this form, okay, this is essentially what used to be called y equals mx plus b form. So what do they really want you? They want you to plug in -3, and they want you to plug in -2 to see what it gets out. So let's go h of x is equal to 3x. So again, h of x is equal to -3x, and they want you to evaluate it -3 and -2. So if I said h of -3, all that means is, hey, what's -3? And I'm going to plug in -3, and then they want you to do h of -2, which is -3 times -2. Well, -3 times -3 is 9, and -3 times -2 is going to be 6. So as these numbers went up by 1, these numbers went, well, from 9 to 6, that's going down by 3, which is just going to be this number right here, okay? So it's going to decrease by 3, not by a factor of 3, by 3, okay? So again, for this one, if I plug in 1, well, 1 plus 3 is 4. If I plug in 2, 2 plus 3 is 5. So there's a change of 1. But again, this is 1t, right? We don't write the 1 there, but this is just a change of 1. It's a positive number. It's changing by 1. Here, again, all you need to look at, how does g of x change over the interval from x is equal to 5 to x is equal to 6? It's going to change by 3, okay? But again, just to show you, 3 times 5 minus 8 and 3 times 6 minus 8. Well, 3 times 5 is 15. 15 minus 8 is 7. Plug in 6. Look at 6. 3 times 6 is 18. 18 minus 8 is 10. So it went from 7 when I plugged in 5 to 8. I'm sorry. Let me write it out. I'm sorry. Trying to do this fast for you guys. And okay. Again, if I plug in g of x is equal to 3x minus 8. If I plug in 5, it's 3 times 5 minus 8. And I have g of 6, which is 3 times 6 minus 8. 3 times 5 is 15. 15 minus 8 is going to be 7. 3 times 6 is going to be 18. 18 minus 8 is going to be 10. So again, as these change by 1, these change by 3, which is just this number right here. Okay. You can't always go by that because if here they're very nice. They gave you a growth of 1. If it was growing by 5, then we'd actually have to go and do some work. And I can show you some shortcuts different when we get to that. So again, all you're looking for here is your slope. It's negative t. So remember that's negative 1t. When there's no number here, that's 1. So it's going to decrease by 1. Okay? This one's going to decrease by 2. They're just pretty much asking you your slope. Okay? And that should be about it. Okay, so let me know if you guys have any questions, and we'll take it from there. Thanks, guys.